Greetings, students. Greetings, students, EDUC 225 students. This is Irvin Howard, and I'm coming from you in Georgia, and I hope this is adequate because I'm trying to create a video to cover the 9.6 series that's outlined in the textbook, 9.6, entitled Series. And we just talked about, from our last class session, about sequences. And sequences and series are similar. One thing you need to find out, that in sequence and series you always have to find a fixed number and then find the difference between the number that is multiplied by the fixed number and find the difference between those two numbers. But with the series, you're going to find the differences among a sum of numbers as outlined in the notes. Just look at the notes for section 9.6 and just study the difference between arithmetic sequence and a arithmetic series, and then a geometric sequence and a geometric series. And you'll note that the difference between these sets of numbers is that in a sequence you have numbers that are increased by a fixed number, and in order to get the succeeding number, you add or multiply the fixed number to get the next number. Now, when you're adding and subtracting numbers to get the succeeding numbers, that occurs in arithmetic series or a sequence. If you're multiplying and dividing numbers by the fixed number to get the succeeding value, then that's in a geometric series. And I'll show you the difference between the two. But let's look at some homework examples that's outlined in your textbook. And we'll just look at a few problems. Matter of fact, I'll try to do at least 3 problems. And just to kind of coincide how to solve these problems while you're trying to work them at your home or wherever you are. But let's start with the first homework problem. Number 1 is to find the series for this number. I believe this may be a type of arithmetic series, but this problem is expressed in exponent form, and that's okay. That's okay, because I'm going to write the problem down. 1 plus 4 plus 4 squared plus 4 to the third plus 4 to the fourth plus 4 to the fifth plus 4 to the sixth. Okay, I believe this may represent a type of geometric sequence, or it could be a geometric sequence series, or a arithmetic series. But note that in the problem versus what in the problem that's outlined in the textbook, and compare it with the notes that you have in chapter 9.6, you see the numbers are already calculated. Now, instead of saying 4 to the second power, this could be 16. 4 to the third could be 64. And then so on. So you would have a series of numbers, 1 plus 4 plus 16 plus 64, and so on. But instead of writing all these numbers out, the problem is outlined in exponents. And I want to show you that using the exponent form, it's a little easier, because the problems that you're going to do in the book will express exponent form, at least some of them. All right, but regardless, you'll still be able to do the same thing. Use this to solve in finding the sum of a series. Okay, so let's get started. So the first step, after you write the problem, the first step, I like to say not the first step. Let's just say find the fixed number. All right? And then we'll outline the individual steps. Find the fixed number. What is the fixed number that is shared among each of these numbers? Now, note from sequences, in order to find the fixed number, you have to compare the numbers given in a sequence and how they behave, or how are they increased by certain numbers to get the succeeding numbers. So in this situation, by showing this in exponential form, you can see that 4 is the fixed number. Now, if you solve the problem and just write it out in its numerical form, you could probably see that 1, it begins with 1 plus 4 plus 16 plus 64, and you can no doubt see that these are increased by 4. All right, so look at the pattern and see how the numbers are increased in order to, how each of these sums are increased by looking at the preceding numbers and then looking at the succeeding. Preceding is the number before the succeeding number. All right, so in this case, it's 4. All right, now the steps to find the sum, step 1. Okay, so in step 1, we find the fixed number, which I just noted, so that you recognize that this could be your sequential step. All right, so find the fixed number, which we already did, which is 4. Okay, now step 2, multiply the fixed number for S. And I want to explain that. I'm glad they have this right here. Now, in order to carry out the multiplication, you're going to have at least 2 of similar sets of series numbers. All right. Now let's go back to number 1. Now, because this is the given series, all right, we're going to designate this as S. So designate the given series, or S, let me erase this. Okay, designate the given series as small s. Okay, so S will be the given series, that the problem that you've started out with. 1 plus 4 plus 4 to the second plus 4 to the third plus 4 to the fourth plus 4 to the fifth plus 4 to the sixth. So this is your given S. All right. Now back to step 2, multiply the fixed number for S. So what we're going to do is we're going to take this part, okay, we're going to multiply it by 4, which is 4S, okay? So all we're doing is we're multiplying 4 by the given series that we started out with, okay? By the given series that we started out with. So we're going to multiply each of the numbers from S, okay? And then we're going to do something. Now, what we're going to do, since we're going to multiply, here's the side note. This is Scratch. All right, so that you understand what I'm doing. Now, we're going to use, in order to multiply this, we're going to use the product rule. And some of you heard of the product rule. Okay? So, A raised to the power of whatever M times A raised to the power of whatever n is equals to A raised to the power M plus n. That means that if you have the same bases and different numbers, you write the base that they share, and then you add the exponents. Okay? You add the exponents. And this is how it works. For example, the first one. All right. Since we're going to multiply this by 4, it's going to equal to 4. But, okay, so when you multiply 4 times 1, that's 4, okay? That's how we got this one. Plus, we're going to multiply 4 times 4 to the first. So look at this. So when we multiply 4 times 4, all right, so when when we do this, they have the same bases, but they have, now in this case they have the same number. All right, so if there's no number, see, if you have just a regular 4 in its exponent form, it's understood to be 1 raised to the power of 1. When you have these two same bases, okay, you can add the exponents. 1 plus 1, which equals to 4 to the second power. And that's how we get 4 to the second power. Plus, we multiply this 4 times 4 to raise to the second power. If we have 4 raised to the 4 to the second power, okay? All right? So when you add these numbers, the exponents with the same basis, that's 4 to the third. I hope you are getting this. And I'll go ahead and just write it out. All right? So we have 4 to the third plus 4 to the fourth plus 4 to the fifth plus this 4 to the 4 to the fifth becomes 4 to the sixth plus this 4 to the fourth plus 4 to the sixth, which give you 4 to the seventh. So you're going to have these numbers increase by 1, all right, each time. You're going to have it increase by 1. So if you compare 4 times S with S, regular S, you can see here that 4S is increased by 1 in the exponent, okay? All right, and there's a reason for that. Okay, now that we have this, step 3, take the difference. All right, take the difference. Take the difference in this case between fixed number times S with S. All right? So that means that take the difference between fixed number times S, in this case 4 times S, with regular S. I should say regular S, but I would like to say, let's say with given S. With the given S. Because the given is what started this out in the first place. All right? This is the given. Okay? This is the given. Regular S. Given S. As S. All right, so what we do is we write this. We write it in form of an equation. S, 4S, okay, minus S. All right? Draw a line. And then we write those values that are represented by 4 times S with S. Okay? So this is what happens. All right? This is what happens. All right? And then when I bring it down, you're going to have the equal sign. All right? We're going to have an equal sign, but we're not ready for that yet, and I'll show you. All right? So we're going to write what the answer obtained in 4S. We're going to write it here. 4 plus 4 squared plus 4 to the third plus 4 to the fourth plus 4 to the fifth plus 4 to the sixth plus 4 to the seventh. Okay? So that represents 4 times S. This is what that is. Okay? Then we're going to take minus. Now, since we have a minus, that means that you're going to have whatever S is represented by these numbers, each number is going to change to a negative because you're multiplying a minus, which means that it's really a negative times s. So everything is going to become negative, and I'm going to place this in parentheses. All right. Okay, I hope you can see this. I'm going to place this in parentheses just to show you. All right. So we're going to have, what is s? You have this 1. That becomes negative 1. Okay. All right. That becomes negative 1 plus negative 4. All right. Okay. Well, you don't even have to put the plus. This is a good idea, because with this, everything that was plus, okay, it's going to change into a negative. And let's do that. So that becomes minus 4 squared minus 4 to the third minus 4 to the fourth. You see what's happening? They're going to cancel out later. Minus 4 to the fifth, minus 4 to the sixth. All right. All right. So this is what you have. All right. So that means that all of this cancel. This 4 cancel, 4 square cancel, 4 to the third cancel, 4 to the fourth, 4 to the fifth, and 4 to the sixth. And what you have left is, when you take this, all right, because when you take the difference, 4 minus regular s, this is understood to be 1. So you'll have 3s, and then you bring this negative 1 down, negative 1, and then you have plus 4 to the 7. Isn't that beautiful? All right. Isn't that beautiful? It worked out wonderfully. All right. So all you're doing is just comparing these numbers and then canceling out like terms. Okay. All right. You're canceling out like terms. Let me get another pencil. Okay. And then this is what you have left. 3s equals to a negative 1 plus 4 to the 7. Now, here's where the rubber will meet the road, but it's going to be a nice ride. All you have to do is solve for s. How do we solve for s? We divide 3 on both sides of the equation, because this is an equation now. So we do that. We have 3s divided by 3, negative 1 plus 4 to the 7 over 3. And I'm going to make a little loop here, and so that you can see where I'm going. I'm going to write this as s, which is, so they cancel out. So you have s equals to 1, negative 1 plus 4 to the 7 over 3. We're not quite done yet. We have to solve for whatever 4 to the 7 is, and that is negative 1 plus, so 4 to the 7, the 4 to the 7 is equals to, let me get my 16,384 over 3. All right. And then if you, all right, so this is the equation. So you solve it. All right. So when you take away, when you add negative 1 plus 16,384 divided by 3, all right, you can put in your calculator, the answer will be 5,461. Okay. So we go back to the original equation, or the series. 1 plus 4 squared plus 4 to the third plus 4 to the fourth plus 4 to the fifth plus 4 to the sixth, which is a sum, equals to 5,461. All right. So the series is actually a prior knowledge piece to prepare students for calculus, because you're going to see a lot of summations. All right. You remember the summation symbol that you see in calculus? This summation symbol, it's like a side M, all right, upside down, turned to its 90-degree counterclockwise summation symbol, which is a precursor or prerequisite for understanding and solving calculus problems. Okay, so let's look at another one. let's look at number 2 in your textbook, the homework problem in number 2. And this one represents a type of infinite series. That means that the exponents, they keep going on. All right, let me give you an example. And we're going to use the same similar problem. All right, we're going to use the same similar problem that's outlined in number 2. All right. So this is number 2 in the homework problem. 1 plus 4 plus 4 to the second plus 4 to the third plus 3 dots. This means infinity. All right, so it's an infinite series. Plus 4n. Okay, so that's going to be a little tricky because we don't know what the value of n is because it doesn't stop. It keeps on going. But we can find the summation or some type of equivalent summation formula once we follow the steps. So like before, all right, step 1, find the fixed number. All right, so when you find a fixed number, you look at the series and examine how each of the series, the numbers in each of the series are increasing. So they're increasing by 4. So in this case, again, 4 will be the fixed number. Then we designate step 2. All right, step 2. Let me pull this out. All right, I'm sorry. Okay, this is back. All right, okay. All right, step 2, let let's say multiply, and then I'll explain. Multiply the fixed number, all right, by s. All right, here we go again. We're going to first designate the given series as s. Okay, so we're going to designate the given series as s. That means that s will equal to 1 plus 4 squared plus 4 to the third plus 3 dots, which is infinity, 4 to the n power. Okay, now this is where we'll multiply the fixed number by s. 4s. Okay, so we're going to multiply everything that was s by 4. So in this case, we're going to have 4. Let me put on here. Plus 4 to the third plus 4 to the fourth plus 4n, then the 3 dots, plus 4 to the n plus 1. Okay, it's like I said before from my the first problem. Each of these are increased by 4. So when we're multiplying by the exponents with the same basis, we add them. So when we added 4, this is 4. When we said 4 times 1, this is 4. 4 times 4 to the second. When you have 4 to the second plus times 4, you add the exponents, that would be 4 to the third. All right. So I just went ahead and just done this straight so that you could see that this is a shortcut. I didn't have to show how I got it because you can see that from your first video. Okay. Well, from the first problem in the video. All right. So once we made these increases, step 3, find the difference. All right, find the difference. All right, so we have 4s minus s. All right, and you're going to be able to see and then we're going to set this like an equation. All right, this is the equal sign. All right, we're going to set it like an equation. We're going to write all the elements that represent 4s, which is 4 plus 4 to the third plus 4 to the fourth plus 4 to the n. Okay, plus the 3 dots, 4 to the n plus 1, and then minus. So the negative is going to change all these values. All right, instead of plus, it's going to change it to negative because you're multiplying negative 1 times s. So you'll have negative 1 minus 4 minus 4. I did it again. This is 4 to the second. All right. Okay, let me go back here quick. Let me change this. I left 4 to the second out. I apologize. All right, I apologize. All right, let me erase this. All right, I can do this in the video. I made a mistake. All right. Okay. All right. Let me fix this back. This is 4. Right, 4 plus 4 to the second plus 4 to the third plus 4 to the fourth. Okay, plus 4 to the, I just want to make it correct. It's the same thing. Plus 4 to the n power plus dot dot 4 to the n plus 1. I just left out an exponent. All right, so this is 4 to the second, 4 to the third, 4 to the fourth, plus 4 to the n plus dot dot 4 to the n plus 1. Okay, all right. Okay, I just left out 4 square. I apologize. All right, square minus 4 to the third minus 4 to the fourth minus 4 to the n plus the dot dot. All right. Okay, because that's as far as it can go. All right. Now, okay, I hope you can see that. I made a mistake. I left out one of the exponents. Okay, so that's all done. But it's the same situation. It's going to cancel out. If you can remember these values and try not to leave them out, just like I just did. I left them out when I miscounted. All right, so these cancel. Okay, they cancel. So 4s minus s, you have 3s equals to, you have this negative 1 left over, and then you have plus 4 raised to the power of n plus 1. Isn't that beautiful? I'm going to sharpen that pencil. Okay, all right. Okay, all right. Okay, now we have this. Okay, and then I'm going to do this. 3s equals to negative 1 plus 4n plus 1. Okay, solve for s. All right, we solve for s. All right, so we have to get rid of the 3, so we divide 3 on both sides. All right, so then we have s equals to negative 1 plus 4 raised to the power of n plus 1 divided by 3. All right. Now, or you can say 4n to the power of 1 plus 1 minus 1 over 3. Whichever way you want it, you can have that problem. I'm going to work the next problems in the next video, and I'll show you another example, maybe 2 examples. Okay, you have a good day and prepare to watch the next video.